get this? How many of you can quickly get this? Find the dimension of magnetic flux. Magnetic flux. Come on. This kind of question can come. This kind of question can come. Dimensional formula of magnetic field, magnetic flux, etc. Flux is magnetic field into area. Do I know the dimensional formula of magnetic field? Think about it. Or is there any other formula? Think about it. Come on, my dear warriors. Yes. Q square. Oh, sorry. I forgot that Q square. My bad, guys. I forgot that Q square. I'm so sorry. Yeah, Q square I forgot. So it would be ampere square. My bad. Ampere square and T square. Nothing but magnetic field into area. Can I write down field in terms of something, because it is not a fundamental quantity anymore. I know force is equal to ILB. Magnetic force is ILB. I think we can use that. So if I use the concept force is equal to ILB, therefore magnetic field will be force by current into the length. So why not substitute it over here? Instead of magnetic field, put it as force by current into length and into area. Okay, so therefore the dimensional formula of the flux will be dimensional formula of the force multiplied by area, check this out, divided by basically your current is there, and of course the length is also there. Force, guys, is m raised to 1, l raised to 1, t raised to minus 2. Everybody with me? M raised to 1, l raised to 1. Very good. Awesome. Next, what is area? Length square. Area is nothing but length square. Current is nothing but amperes, and length is nothing but length. So from this, what you will get? You'll get m is raised to 1. L will get cancelled. L raised to 2 will remain. T raised to minus 2 will remain. And ampere raised to minus. You want to study chapter number 10. So those recorded classes are also available. But the entire batch heard the JEE crash course plus boards plus VIT triple this one JEE plus boards. All these things are purely live. Okay. But you also get additional free of cost recorded classes as well. Okay. Awesome. Good morning, Jeffrey. Shall we see the next method, my dear warriors? How do you do it with the units? Now? See, I'll tell you. If, example, there is a physical quantity whose units are, for example, it is that you know the unit. How many of you understood it? Give me a thumbs up quickly. Yes, quickly give me a thumbs up. Awesomeness, my dear warriors. Perfect. Very good. So these are the two ways you can find it out. There were what is the dimensional formula of capacitance, what is the dimensional formula of P by this, etc. Such things were there. Okay, I can give you one more question. Say for example, they give you what is the example. Let's say they give you what is the dimensional formula for. Let's say permittivity. How are you going to do this? Come on, many people will be shocked. Many people will think, oh sir, how to find permittivity dimensions? What is the formula? There are many formulas, but try to think of the easiest formula which will help you. Because again, mu naught's dimensions, energy density. I think you can use energy density. Yes, think about it. How energy density? The energy which is there per unit volume is nothing but half epsilon naught electric field square, and electric field is forced by the charge. This is nothing but energy per unit volume. Therefore permittivity will be 2 times of energy, and this volume is there below only, multiplied by the charge square divided by the force square. Now all these things you know. So permittivity is a dimension. You can find it out using energy dimension, which is m raised to 1, l raised to 2, t raised to minus 2. Charge is current into time, so it will be ampere into time raised to 2. Volume is length cube, so L cube will come over here, and force is m raised to 1, L raised to 1, t raised to minus 2 the whole square. Solving this, you will get the answer. Got it? Very good. Awesome. Excellent. That's how you can easily do this. Perfect. So there could be other formulas also through which you can approach it, but I'm just giving you an approach method. Now, remember, there were also questions on homogeneity or basically, apply the principle. This is the one of the first rules. Next rule, you can either add or subtract. You can either add or subtract if they have the same dimensions. Dimension 1, dimension 1, yes. Dimension 2, dimension 2, yes. So this is definitely allowed, but what is not allowed, let's say this is d1 and you are adding it with some another dimension d2, so this obviously is not allowed. Okay. Also remember that when you multiply dimension 1 multiplied by dimension 2, you get the total dimension d1 d2. Example like m raised to 1 l raised to 2 multiplied by m raised to 3 l raised to minus 1 is m raised to 4 l raised to 1. So it is definitely allowed. That is definitely allowed. And also even division of dimensions is allowed, like d1 by d2 you can definitely do. That will be d1 by d2's dimension. This is also, there is nothing wrong with this. Is this clear? This will be a long class, funny guy, don't worry. Yeah, because we have to do all the revision and the concepts as well. Okay, clear? This kind of questions were definitely asked in the examination about mc square. Momentum is nothing but mass into velocity. Also, energy is momentum square by 2m. If you know these formulas, easily you could solve this question. So the point, the formulas of many chapters, and only then you will be able to do this question. Okay, so these kind of questions were definitely asked. All right, and if by chance they ask you to convert from one unit to another unit, right now there was no question, but in case they ask, because they have been fond of dimensions and they can throw a surprise of conversions. And example, they say there is a physical quantity and you have to convert the units. You have to convert the units. You have to convert the units. Let's say that particular physical quantity, has the dimension of m raised to 2, l raised to minus 1, e raised to minus 2. Okay, this is the physical quantity, and you have to find the SI unit conversion to the CGS unit conversion. Okay, SI unit conversion to example CGS unit conversion. You know the dimensions, or you have found out the dimensions. How do you do that? From SI unit, you have to convert it into CGS unit. So one SI unit, how much will be one in CGS? Okay, now kg. Kg is how many grams? 10 to the power 3 grams. Yes, is that right? 1000 grams is 1 kilogram. Then meter. How many centimeters is a meter? 100 centimeter. 100 centimeter is a meter. Okay. Second, there is no conversion at all, so keep it as second only. Okay, because in SI units and CGS units, second is second. Okay, in both the things, time is measured in seconds only. 10 to the power 3 raised to 2 will make it 10 to the power 6. Then this gram square will leave it as it is. 100 raised to minus 1, just think of it as 1 by 100. And this is s raised to minus 2. This will become 10 raised to 6 and 2 zeros will cancel. This will become 10 raised to 4 grams centimeter raised to minus 1, second raised to minus 2. This is basically 10 4 CGS units. So 1 SI unit is 10 to the power 4 CGS units. Understood, guys? All right, everyone clear? Everybody clear about this? Everybody clear about this? Understood? Shall we go ahead? Great. Okay. Now, also there were very few questions on errors. Please keep this in mind. Error in this quantity. Forget the constant. Take the modulus of the power, relative power of 1, plus take that modulus of that power into relative error of that second quantity, plus take the modulus of the power, relative error of that third quantity. So this formula based question can be asked. You can also write or rewrite this as percentage. If everything is measured in percentage, LHS, RHS will also be percentage. Example could be say if the radius of a sphere, if the radius of a sphere changes, radius of the sphere changes from 1 or let's say r to let's say 1.02 r, and mass by m to 1.04 m. Find the percentage change in density. Find the percentage change in the density. Now this can be a brilliant question. Many students will make 3 on the top. So 3m divided by 4 pi r cube. So write it in the power formula. You will write it as 3 divided by 4 pi is the constant. M raised to 1, r raised to minus 3. So what will you write? Delta rho by rho in percentage, or let's say relative error also, is, forget the power is 1. So 1 multiplied by relative error in mass plus r power is, sorry, this is minus 3, my bad. This is 3, so the modulus is 3. So 3 into r by r. Is that right, my dear students? Understood? First, write down the formula of that quantity. Write it as constant into the powers multiplication. The powers will come as positive values. Never take negative values over here. Next thing, just multiply it with the relative errors and add. Is that right? Okay. Now quickly put it up in the chat box. The radius change which is there, how much percentage is it? Delta r by r. How much percentage is it? Also tell me mass wise how much is delta m by m in percentage or in relative error. Can you see that, my dear students? The radius has changed by from 1 to 1.02. So that is basically 2%. Awesome. Now what you will do over here is a delta rho by rho percentage wise is delta m by m. What is delta m by m? Delta m is nothing but 4%. Put it over here, plus this particular thing which is nothing but 3 multiply this particular quantity which is nothing but 2%. So 3 2s are 6, 6 plus 4 is 10. You are going to get it as 10%. You are going to get it as 10%, my dear students. But is this the answer? The answer is no. Is this the answer? No. This is not the answer. You know why? You know why this is not the answer? You know why? Anybody can tell me why this is not the answer? Yep, lot of you are going to make a silly mistake, and such tricks JEE can ask. I'll tell you why. Read the question carefully, you will realize it. The radius has increased. Even the mass has increased. Look at this formula. If the mass increases, because of that, the density should increase. Correct? If the mass increases, the density should increase. But if the radius increases, the denominator will increase, the density. When r increases, the density decreases. Is that right? So that is why there is a negative contribution. That is why I will say that this answer will be 4% minus 6%, which is negative 2%, means the density reduces by 2%. That means the radius increased much more as compared to the mass in the effect of density. Got it? Yep. Beautiful question. Everybody loved it, I hope. Yeah? Give me a thumbs up. I hope you have smashed the like button and subscribe to the JEE English channel. If you have not yet subscribed, you guys are at a loss, a big loss, especially for the second attempt, this attempt, the other exams, JEE Advanced, every preparation is going to happen here in the CBSE boards. So you need to be prepared thoroughly on this channel. So for that, subscribe and like this particular video. Okay, very good. So that was all about dimensions. Let's go to the next concept of projectile motion. Which concepts have been repeated? Which formulas have been repeated? Let's talk about projectile over here.